Hello, this is Karen Rhodes with HP Networking, and in this video I'm going to show how to configure stacking on the HP 3800 series switches. Okay, so in this video we're going to go through how to activate stacking and setting the priority on the different switches, show you the different stacking options as far as the cable layout, since this is a 4-port stacking module on the back of the switch. It is giving you a lot more options as far as having a ring or having a full mesh, or just doing a standard stack. Then we're going to show you how to replace the master in a stack, then resetting the priorities to your factory defaults. Then I'm going to show you how to disable stacking finally. So if you look at the right hand side, you'll see these are the switches we're talking about. The front panel is a simple 24 port, 2 ports of 10 gig SFP plus, and then on the back you see that you can have dual power supplies and fans. Those are hot swappable, and then the card that's in there is a 4-port stack module, and you'll notice that each one of the ports actually consists of 2 ports, so it's a much thicker cable than like an SFP plus type cable. Okay, so what we're going to do first is look at the layout here. Left hand side is the top switch, right hand side is the bottom switch. First thing that we'll do is on the top switch we will configure the host name, and then we'll activate stacking. We'll give it a member number of 1 and a priority of 255. Then we'll hop over to the bottom switch. We'll give it a host name of bottom, and then we will have the stacking enabled as member 2, priority of 200, so it has a lower priority than the top switch. Whenever we do that, both of those switches will reboot because we are enabling the stacking module. So after they reboot, we'll do a show run on both switches just so that you can see the config. On the left hand side, top switch, you'll see that we will connect the cables after we do that show run, and the master switch will not reboot. So the top switch will be the master, it will not reboot. The bottom switch on the right hand side though will reboot in order to join the stack once we connect the cables. So let's do the config. Okay, so this is our first switch, and first thing we want to do is give it a host name of top so that we can differentiate it from the other switch. Once we've done that, then we're going to enable the stacking, so stacking enable, and then give it a member number of 1 and a priority of 255. Once we do this, it will go ahead and ask us to save the config, and it will tell you, do you want to reboot? You will want to reboot in order to activate the stacking. Now let's go on to the next switch. Okay, now we're on the other switch, and first thing we're going to do is give it a host name to differentiate it. So host name is going to be bottom, really inventive there. And then we're going to enable stacking. So stacking enable, and we're going to have this as member number 2 and a priority of 200 rather than 255, so it does have a lower priority. Once again, asks you to save and tells you that it's going to reboot, and of course we want to do that. Okay, now we're back on the top switch. It has rebooted, and whenever we do a show run, we see that stacking is enabled. It is member 1, and it does have a priority of 255. Okay, the bottom switch is now rebooted. We do a show run, and we see that the stacking is on. Member is number 2, and the priority is 200. So at this point, we will go ahead and connect the stacking cables, and member 2, which is the bottom switch, will reboot. So to review what we've done, we've activated stacking after giving each of the switches a host name. The switches both rebooted. We did a show run to show that the switches did have the stacking configuration in them. And then right after that I went ahead and connected the cables. To save time on the video, basically the top switch does not reboot, the bottom switch does reboot, and that's because the top switch is the master in the stack. Okay, so next we're going to do a show run and then show stacking on both the top and the bottom switches, just so that you see that they both will have the same config there. And then we're actually going to switch which one of these switches has the master and which of them is just a stack member by using the Redundancy Switchover command. And whenever we do that, the 2 switches that are involved in trading places will reboot. Okay, so the bottom switch did reboot. And if we look at the top switches config, we now see that stacking is still enabled, but instead of just seeing member 1, we see member 1 and member 2. And we do see the priorities for both of those members. Now we can also do a show stacking, and we see that 255 switch, which is the switch number 1, which is the top switch, is the commander, and the priority 200 switch, which is our bottom switch, is set to standby, which is what we expected it to be. Okay, so we're actually on the other switch now, but you see that it says top, and whenever I do a show run it shows our two members, and whenever I do show stacking, it shows the stacking identical to what we just saw a moment ago, with 255 being the commander and 200 being the standby. This is because this environment is now in a stack, so you have one solid config rather than a config for every switch. Okay, so the next thing we wanted to do was actually show how you can flip these from the commander to the standby. So redundancy switchover is how you do that. It'll ask you, do you want to reboot? And you do have to say yes if you want to reboot and change your commander and your standby switch. Okay, so both switches in my lab have rebooted, and if we do a show run, we see that we do still have two members in our stack, which is lovely. And then if we do a show stacking, we will see that the priorities are very different from how we had it before. So the 255 is now the standby, and the 200 priority is now the commander. So we have successfully flipped these two switches so that the bottom is now the commander and the top is now the standby. So if we wanted to reset these priorities, I'm going to sneak a command in here. If you wanted to reset them to factory defaults instead of this 200 and 255, you would do that with the command stacking space factory dash reset. And whenever you do that, it will say that you need to reboot once again. So quick review, we went ahead and showed the running config and the stacking on the top and the bottom switch. They were identical, with even the same host name because they are the same config now. And then the redundancy switchover, we did that, and the two switches that were flipping positions did go ahead and reboot. Okay, so we've actually already done the stacking factory reset, and you saw that in the very end of the previous little video snippet. And now we're going to go ahead and disable stacking altogether. Okay, so after the factory reset, we see our host name is reverted, and that our stacking priorities are now 128 rather than 200 and 255, which is definitely what we expected. We do a show run, and we see that the stacking does still show two members in the stack. And next thing we're going to do is try to go ahead and actually disable this stack. So I want to show you an error message first of if you go into config T and then you do stacking disable, you're going to get an error message here saying that you need to save your config. Do you know that it's going to reboot? Yes. And then it's going to say, I'm sorry, I can't because the stacking port is still connected. So let's go ahead and do that, and then we'll show you what the result is after we disconnect the cables. After disconnecting the cables, I went ahead and issued the stacking disable command again, and the switches did reboot, and now you see that there are no stacking configurations within this config. Whenever we do show run, it doesn't show up, and then whenever we do show stacking, it does say that stacking is disabled. So we know that we have fully removed stacking from these switches. So in review, we did a stacking factory reset. All the switches in the stack did reset to go back to those factory parameters. Then after that, we decided to destroy the stack by doing stacking disable. We got an error message whenever the cables were connected. We disconnected the cables, ran the same command, and then all switches did reboot, and they were independent of each other after that reboot was completed. Okay, now that we've looked at the configurations, let's look at the cable options. So on the left hand side, you'll see that we have the ring or the stack topology option, and those actually go up to 10 switches. I only put 5 in the presentation here to save space. But on the right hand side is the much more interesting option, which is the full mesh. Since this is a 4-port stack card, you can do a full mesh for a very high speed mesh between up to 5 switches. If you are going to do that, I advise that you go ahead and print out this screen just so that you have the mesh cabling options easily at hand. They can be a little bit confusing at first, but once you do it a couple of times, you realize it's not all that hard. Well, thank you very much for taking the time to watch this video. I hope you found it informative and that you enjoy using the high-speed 3800 stacking options that are available from HP. If you do ever have any questions, by all means, please contact our support at 1-800-334-5144. Once again, that's 334-5144. Whenever you buy our switches, you get the support. So please, by all means, use that support Monday through Friday, 9 to 5. We want to make sure that you are getting the most out of your products on a daily basis.